Welcome back, and I've got a really unusual experiment for you today. I call this one the crazy eraser or the Rattleback. And then all you do is just put your drink down on the bar and you leave it alone. I'm not sure you expected that to happen, and neither did I. So let's try and explain what's happening. Electric fields apply forces to charges. Why does putting two transparent things on top of each other do something so strange when you turn it through 90 degrees? Oh, and today we've got Laika the space dog with us as Pippin the pony is off on another one of the world travelling missions, and more of that at the end. So something really odd happened in one of my lessons a while back. I was teaching the second form, and one of the girls, Izzy, had this little Nemo-shaped rubber eraser on her desk and was sort of flicking it around, and it was doing some really weird things. It seemed to be really defying the laws of physics. So what I thought I'd do today is, because I borrowed it off her, is show you what this does and try and explain to you the weird physics that's going on. So I came over to check the work that they were doing, and she was playing with this and sort of spinning it around on the desk. And it was hardly surprising that when you spin it, it stops. There's quite a lot of friction between the desk and the eraser. But once when she spun it, it flipped over and its behaviour was completely different. It spun much more freely, and on occasion, and I'll zoom in so you can see this, it sometimes spun and then spun back a bit, which it did then, which was very, very strange. So let's have a closer look at this. So now for a bit of an explanation. When it was this way up, it spun and stopped, and in both directions it just spun and stopped. So it's rotating and it's rubbing against the desk because there's quite a large flat surface area here to change its rotational energy, its kinetic energy, into heat via friction on the desk. But when you flip it over, it's not actually the same cross-section on the other side. It's a bit more raised on this side, and that affects how it behaves when you rotate it. So the other way up, it rotates in both directions quite freely. And just occasionally you notice it spins, and it'll actually spin backwards. It did it again then, okay, which is quite unusual. But the other thing you'll notice is when it spins and also shakes from side to side, and you saw it rolling backwards then. And what it's doing is it's converting its angular momentum in that direction to momentum in the twisting direction. And so it's swapping between the two. And then it's going back into rotational motion. So what it means is that it'll rotate and slow down, put its energy into shaking in this direction, and then convert its energy back into rotating. Now, the physics of why it swaps directions and why it swaps between the two are really complex and quite mathematical. But that aside, you can see the effect just with this rubber, just with this eraser. It doesn't happen always, but from time to time it does. But what's interesting is you can see the shaking motion. You can see it rocking from side to side, and so you can see it converting its energy into motions in different directions. And that got me thinking about something I'd seen before. So after seeing this in the lesson, I remembered something called the Rattleback, and you can get these really cheaply on the internet, the usual sort of sites. I was surprised. I think it was only a few pounds or less, in fact, including the postage, and I think it came all the way from China. Anyway, this is a Rattleback, and you'll notice that it has not a constant or uniform cross-sectional area. It's flat on one side, and we talked about the flatness of this, and it's curved on the other, but even the curvature isn't even at all places. So let's swap these round and have a look at this one. And if we spin it this way, it spins quite happily. It shakes from side to side a bit. But if we spin it in the other direction, it really doesn't like that. And in fact, you can hear it clicking as it shudders, and it does that rolling back motion really well. So it rotates, shakes, and then rotates back. And once it's done enough work on the desk, there's friction between it and the desk, all that energy that was kinetic is converted into heat, and it stops. So it just goes to prove as a teacher, when you see children playing around with things and perhaps not doing the work they should have been, they might find out something really interesting. And I was really pleased to see this really odd effect with this Nemo-coloured rubber that does radically different things depending even on which way up it is. So thanks to Izzy and Molly who were playing with this. I've had a lot of fun trying to work out the physics of it. And perhaps you can buy yourself a Rattleback. They're a lot of fun, and see if you can demonstrate this effect yourselves at home. So I hope you enjoyed that video, and I look forward to seeing you again next time.